let's look at a rational function, meaning that there's a ratio somewhere there, and determine the domain. Now, when they say the domain, what that really means is they're asking, is there a problem with this function? Can there be a problem? And when you're trying to plug in your x value, instead of a number, it gives you undefined. Is that possible or not? With polynomials, that was not possible. No matter what you plug in, you always get an answer. But with the ratios, what is the problem? Division by zero. What I want you to do is when you determine the domain, do not look at the numerator. It doesn't matter what's happening there. The only thing that matters is the bottom. Set the bottom equal to 0 and solve for x. Okay, usually this would be something that you can easily factor. This is called the difference of squares because you have x squared minus 7 squared, right? Think of it as x squared minus 7 squared. This is easily factored as x minus 7, x plus 7. Okay, and then once you factor it, then it's very easy to figure out when this thing is equal to 0. Because you can use something called zero factor property. It just means that either this guy equals 0 or the other one equals 0. And that's not hard to solve, right? We're just going to add 7 to both sides here, which is going to give us 7, and then subtract 7 from both sides on the other one, and that's going to give us negative 7. These are the only values where you might have a problem, so you're going to have to put 7 and negative 7 over here. By the way, one thing you could do is try to plug in one of these numbers into the function on a calculator, and the calculator is going to say, excuse me, what the heck are you asking me, because this is not right. Now, how do I write this in interval notation? So this is going to be the tricky part, okay? I am going to show you this on the number line, okay? So this is your number line. Let's get closer to it. And remember, we want to exclude 7 and negative 7. Okay, so what we're going to do is we're just going to draw these circles, like empty circles, around the points where we are excluding the values. Really, what we want is just to pluck those two numbers out of the number line, and everything else is okay. So what we're going to start is over here we have negative infinity, so we're going to start at negative infinity. We're going to go all the way to negative 7, but we're not going to actually touch it. You can't touch it. It's like you're going to burn your hand if you touch it, okay? Because that's negative 7, you got a problem, you got to take it out. And then you're going to again start drawing your interval, right? All the way up until 7, and at 7 again, you got to pluck it out because 7 is not okay. And finally, again, you're going to start at 7 and go all the way to positive infinity, which is here. So how do we write this using interval notation? Well, you're going to need 3 different intervals. This is interval number 1. This is interval number 2. This is interval number 3. For number 1, you're going to start at negative infinity and go all the way to negative 7, right? And then stop. You need to use parentheses because negative 7 itself is not included. You cannot touch it. Then the next interval, number 2, is going to start at negative 7 and end at 7, right? So it's from negative 7 up to 7. And finally, the last one is going to start at 7 and go all the way to positive infinity. Now, in math, when you combine intervals, you usually use it kind of like looks like a U notation, looks like a letter U, but this is like union, add the intervals together. So that's going to be your interval notation. So over here, I'm going to say 7, negative 7 is not okay. And then you can go to interval here to type it. So this is going to be negative infinity, negative 7, then that union thing, then negative 7, 7, again, union, and then 7, infinity. That's what this is going to look like.